Exam number 3 for Tyger White. This is data for our first problem. And we're going to use both Excel and SPSS. Researcher hypothesizes that greater satisfaction after the first session will lead one to attend more sessions. We're going to test this hypothesis and interpret the result. We first did this in Excel. These are my calculations that I figured out. We calculated the Z, X, and ZY from the data of X and Y. And it shows here that we did that by taking the X or Y value, subtracting that mean, for instance, the X of 7 minus the mean of 6, and divide that by the standard deviation. And then we multiplied those standardized values, ZX times ZY, and then we summed them, and that got us the sum of all ZX, ZY values, 5.027508. And we used that to calculate our Pearson's R by dividing that by n minus 1. And we ran our data through SPSS, and this is our results. It shows that our p-value is 0.070. It shows quite a lot of other information too, but that's what our main concern is our p-value. And in looking at our critical value table, we see that the critical value that we have that there on the table is 0.666, and our critical value, our Pearson's R, was less than that. And in addition, our p-value is 0.070, which is more than 0.05. Because of those, we will retain our null hypothesis, and this regression showed that satisfaction after the first session will not significantly lead one to attend more sessions. And we're going to continue with this problem. We go back to the Excel where we calculated the B, which is the slope of the regression line, and A, the y-intercept of the regression line. And we take those calculations from Excel and we plug into this equation here, the regression equation, and then we come up with our predicted y values, and those are shown on this chart. And then I created a scatter plot for X and Y, includes the regression line, and there's the points I listed on the scatter plot with their X's and Y's and the actual X's and Y's. And you'll notice that the X line, it does not go all the way down to 0, which is why our y-intercept was calculated as negative 0.28, but it's not shown on this scatter plot. It's a little bit farther to the left and a little bit farther down. And what percentage of variance in y is explained by X? It's our R square value, 0.395, which is 39.5% of variance in the number of sessions attended by a client after 3 months is explained by that client's satisfaction after the first therapy session. That's a fairly low value. It can be between 0 and 1. The R squared would be 0 and 1, and this is lower than 50%. So it's a fairly low variance. And here, homework 9, problem 2, we would need to fill in this table. We have some given information. We're given the MS of 20 and the SS of 124, the sum of squares of 124 total. And we're also given the number of participants in each group and the total number of groups. We're using that data. We determine the DFs from the data we're given about the number of participants and number of groups. So we can come up with the DFs of 2 and 21. And then we use that information to calculate SS from the MS of between groups, which is 20 times 2 equals 40. And then we can subtract 40 from the 124 that we were given and come up with 84 with sum of squares for within groups. And then we can calculate the within groups MS by dividing the 84 by 21, and that results in 4. And finally, we calculate F by dividing the MS between by the MS within, which is 20 divided by 4, which equals 5, which is our F value. Homework 10, problem 1, we want to determine which mean we will insert in this table so that the resulting data shows a main effect for IV1. Two means differ, then there is a main effect. So we showed a main effect here. The two means are the same. I inserted 20, which resulted in the two means being equivalent. That means there's no main effect. A main effect for IV2, we do it similarly as we did for IV1. They differ, then there is a main effect. If the means are equivalent, there is no main effect. And finally, we want to calculate whether there's an interaction between the IVs. We want to show that there is an interaction between the IVs. Therefore, I inserted 30, which made the differences different from each other, which showed that there is an interaction. Here, I wanted to show that the differences were equal to each other, so I inserted 80 in the blank space, and therefore it showed there was no interaction between the IVs. Thank you very much. If you're interested, there's a great song on YouTube called Statistician's Blues. Thank you. I appreciate you watching.